So here we have the first example. In a situation with, for a single question, you have two pivots and you have to find the unknown forces. For example, in this one, the question is determine the tensions in the string. So you need to find, let's call this one T1 and let's call the other one T2. So we got to find the value of T1 and the value of T2. These two forces are to be found out. So this is the first step. Consider one side as a pivot. Now the force that would be passing through the pivot would not produce any moment of force. So no moment of force would be produced by T2. So we'll be writing the expression for the principle of moment, considering that the end B is the pivot. So end B is being considered as a pivot. If we consider end B as a pivot, so this force T2 would not produce any moment. Now since end B is the pivot, we have to look this side for the reference, and if this is the reference point, this is a pivot, this one would produce anti-clockwise moment, this one would also produce anti-clockwise moment, and T1 would produce clockwise moment. So we'll add the clockwise moments on one side, anti-clockwise moments on the other side. So the anti-clockwise, we have 100 times the perpendicular distance of that force from the pivot, which is 1 meter, plus what is the force produced by this mass, that equals to weight of that block. So if 20 is the mass, the weight would be 20 times 9.81, which would be, I think, 196. Yeah, 196. We can write it as 196. So the weight produced by this force would be 196 Newton. Weight produced by this mass. So 196 times the perpendicular distance of that force from the pivot is, so you see the total is 2 meters. If you subtract this one, you get 1.5 meter till the pivot. So times 1.5 equals, what is a clockwise moment? The clockwise force is T1. So it will be T1 times the perpendicular distance of that force from the pivot is 2. So T1 times 2. Then you can rearrange the equation, you can simplify it. If I simplify this equation, okay, so let's do some mathematics here. 100 plus 196 times 1.5, we get 294.3 equals to 2T1. Then you add these two, you get 394 divided by 2. Then T1 equals to 394 divided by 2. So the value of T1, the tension on the left side of the string, is 197 Newton. In 2SF, you can write it as 200. In 2SF, it would be rounded off to 200. So we're done with the first force. We're done with T1. Now we got to find tension T2. Now there are two possible ways you can find the value of T2. The first way is the same method, but in this case, if you need to find T2, consider the other end as the pivot. So in this case, end A is the pivot. Now this force, since it is passing through the pivot, it will not produce any moment of force. Now this is my reference. I'm going to label the forces which will produce the moment accordingly. So for example, now if this is a pivot, this one would rotate it anti-clockwise, because just try to visualize the direction of the force. This one would move it clockwise, and the force of 196, which is a weight of 20 kilogram mass, it would also rotate it clockwise. If this thing is a pivot, A is the pivot. Now I'm going to add all the clockwise moments on one side and all the anti-clockwise moments on the other side. So what do we have clockwise? Well, clockwise we have 100 times 1. I'm going to write it. First of all, consider B as a pivot now. Sorry, A as a pivot. Yes, A as pivot. So the expression would be clockwise, first clockwise 100 times 1 plus the other one would be 196 times 0.5, because the perpendicular distance of that force is 0.5 from the pivot A. Equals, what do we have anti-clockwise? Only a single force, which is T2. So T2 times 2 meters. Now we shall just simplify this expression. 100 plus half of 196 would be 98, equals to, that equals to 2T2. If we rearrange it, this thing would be 198 divided by 2, and would be just slightly under 100. 99 Newton, or once again in 2SF you can write it as, or it's already in 2SF. I mean, you can round it off to 100 also, to 1SF, but you can leave it as 99. 99 is already in 2SF. Okay, then what is the other way of finding the second force? You see, in all these cases, first of all, in the question it is given that the system is in equilibrium. If it is supported, it's not moving, it is in equilibrium. It's sometimes it's given directly, sometimes it's shown indirectly that the system is balanced. They use different words. Sometimes they would say system is balanced, sometimes they would directly say system is in equilibrium. So if the system is in equilibrium, then the resultant of all forces would be 0. Since we need to find the vertical forces, then I can say if the system is in equilibrium, then the sum of all vertical forces would be 0. What does that mean? It means the forces upward would equal the forces downward. So what are the forces upward? So let's say we have found only the first force. We haven't found the second one. The first force T1 was 197. So this is the method of finding the second force only. But you gotta find the first force by the same method, considering one point as a pivot. So what is the upward force? It is 197 plus there is an unknown force over here, T2, equals, what is the sum of the downward forces? It is 196 plus 100. So these are the sum of the downward forces, and that should equal to the sum of the upward forces because the system is in equilibrium. How do we find T2 from here? Just subtract these two. It'll be 296 minus 197, and T2 would then be 99 newtons. So you see, you get the same answer for T2, 99 newtons. Either way, you're getting the same answer. 99 by this method, and by the other method you were having the same answer, 99. So let us try another example.